Hello viewers, in today's lecture we are going to study about the topic distance of a point from a plane. So here we are going to derive a formula for the length of the perpendicular from a point having position vector A to some plane given by r dot vector n equal to d. Right? So let us derive the formula for the distance of a point from a plane. Suppose we have a plane, say this is a plane, and we are interested in finding out the distance of a point P whose position vector is vector A, right? And we want to find this distance, this perpendicular distance, say PM, right? So we want to find the length of this perpendicular PM. Clear? Now viewers, let the equation of the plane, be vector r dot vector n is equal to d, right? Where this vector n is the normal vector to the plane, right? So this is the normal vector to the plane. Now let us find the vector equation of this line PM, right? So the vector equation of a line we know that it is given by vector r is equal to vector A plus lambda times some vector B, and where this vector B is the vector to which the line is parallel to. Clear? So here we have to write the equation of PM, and so we can write vector r is equal to vector A plus lambda times of vector n, right? Because here this perpendicular PM is parallel to this normal vector n. Now from equation 1 and equation 2, if we substitute this value of vector r here, we get from 1 and 2 we have vector A plus lambda times vector n dot, here we have substituted this value of r in this equation, and here we have vector n is equal to d, right? Now taking the dot product of both these vectors, we get vector A dot vector n plus lambda times of vector n dot vector n is equal to d, right? Now this vector A dot vector n plus this becomes the square of the magnitude of vector n, right? Now taking this term to this side, we have lambda times of the magnitude of square of the magnitude of vector n is equal to d minus A dot vector n, right? And in other words, we can write it as lambda equal to d times d minus vector A dot vector n divided by mod square of the magnitude of vector n, right? So this is the value of this scalar lambda, right? Now what we will do, we will substitute this value of lambda here, right, in equation 2. So let us substitute this value in this equation. So therefore equation 2 gives us vector r is equal to vector a plus the value of lambda is d minus vector a dot vector n divided by square of the magnitude of vector n times, here we have vector n, right? Okay. Viewers, now here we have this important equation, vector equation 3. Now let us consider the vector Pm. Now the vector Pm can be written as position vector of M minus position vector of point P, right? Okay. Now the position vector of M, is given by this general vector r, and the position vector of M can be given by this equation. Why? Because this vector r is a general point on this line Pm, and M is a point which lies both on the plane as well as on the line. So here we have this vector r, and then we have here position vector of P, that is vector A, right? So we have here vector r minus vector A. Now from here, if we substitute this value of vector r, so we have vector A plus d minus vector A dot vector n divided by the square of the magnitude of vector A, and here we have vector n minus vector A, right? Now see, this vector and this vector get cancelled. So therefore we are left with vector Pm is equal to d minus A dot n divided by square of the magnitude of vector n times here vector n, right? Now vector n can be written as here we have this term, and this vector n can be written as n cap times the magnitude of vector n. So here this term and this term get cancelled, and here we have 1, and so this can be written as d minus vector A dot vector n divided by the magnitude of vector n, and here we have n cap, right? So the vector Pm can be given by this vector. Now taking the magnitude of both sides, we have the magnitude of Pm as here we have d minus a vector A dot vector n divided by magnitude of vector n and n cap, right? Now this can be further written as writing the magnitude of vector Pm as simply Pm. Here we have the magnitude of d minus vector A dot vector n and divided by the magnitude of vector n. Since the magnitude of the unit vector n cap is 1. So viewers, this is the final expression for the distance of a point, that is the perpendicular distance of a point P from this plane, right? So we have the vector form of the formula. So let us find the Cartesian form of the formula. Now viewers, let us find the Cartesian form of the formula for the perpendicular distance of a point P from this plane. So let us take the equation. Let the equation of the plane B say we have ax plus by plus cz plus d equal to 0, right? So this is the general form of the equation of a plane, right? Now let the equation of this line Pn, this is the plane, and let the line Pm, the equation of this line Pm is x minus x1 by a, y minus y1 by b, and z minus z1 by c, where a, b, c are the dr's of this normal, and the normal is parallel to Pm, so the dr's of the line Pm are a, b, and c. And here this vector a, which is the position vector of point P, is x1 I cap, y1 j cap, and z1 k cap, right? Okay, so now let us suppose that x minus x1 divided by a, y minus y1 divided by b, and z minus z1 divided by c is equal to r, right? Where r is some scalar, and we have x minus x1 over a is equal to r, y minus y1 over b is equal to r, and z minus z1 over c is equal to r. So from these three equations we can have x is equal to x1 plus ar, y is equal to y1 plus br, and z is equal to z1 plus cr, right? So here x, y, z, which is the general point on the line Pm, right? So x, y, z are the coordinates of a general point lying on this line Pm, right? Okay. Now viewers, this point x, y, and z lies on the line, and let us assume that the coordinates of this point M, are x1 plus ar, y1 plus br, and z1 plus cr, right? And since M lies on this plane, on the plane, therefore it must satisfy this equation, right? So therefore this point must satisfy this equation. So therefore substituting for x, for y, and for z these values, we have a times we have x1 plus ar, then we have b times y1 plus br, and then we have c times z1 plus cr, plus d is equal to 0, right? Okay, now if we simplify this expression, we get ax1 plus by1 plus cz1 plus d, and then we have a square r plus b square b times br, that is b square r plus c square r is equal to 0, right? Okay. Now this expression can be written as ax1 plus by1 plus cz1 plus d is equal to, taking these three terms to this side, we have minus of a square plus b square plus c square times r, right? And r is equal to minus of ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square, right? So here we have assumed the scalar r, and the value of this scalar r is minus of minus times ax1 plus by1 plus cz1 plus d divided by a square plus b square plus c square. Viewers, let us find the length of the line segment or the perpendicular PM by making use of the distance formula. And the distance formula says that PM is equal to x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, right? So here we have, this is point x1 y1 z1, and this is point x2 comma y2 comma z2, and x2 y2 z2 are given by this point, right? So this is x2 y2 and z2. So here we have x2 is x1 plus ar minus x1 square plus y1 plus br minus y1 square plus z1 plus cr minus z1 square, right? Now this is this can be simplified as this get cancelled. Here we have y1 and y1 get cancelled, z1 and z1 get cancelled. So we have the square root of a square r square, b square r square, and c square r square, right? Okay, now we have this expression equal to r times square root of a square plus b square plus c square. Now if we substitute this value of r here, we have minus ax1 plus by1 plus cz1 plus d divided by square root of here we have a square plus b square plus c square and multiplied by this term, right? Square root of a square plus b square plus c square. Now here we have the power of a square plus b square plus c square as half, and here we have 1. So if we simplify it, we get PM is equal to minus of ax1 plus by1 plus cz1 plus d divided by square root of a square plus b square plus c square, right? Because here the power is half, here the power is 1, so 1 minus half is half. Now viewers, here the distance cannot be negative, so if we take the absolute value of both sides, then we get the distance PM as ax1 plus by1 plus cz1 plus d and divided by square root of a square plus b square plus c square, right? So this is the formula for the perpendicular distance of a point P whose coordinates are x1, y1, z1 from the plane whose equation is ax plus by plus cz plus d equal to 0. Now viewers, let us take this problem. Find the distance of the point 2i cap minus j cap minus 4k cap from the plane r dot 3i cap minus 4j cap plus 12k cap minus 9 equal to 0. Now viewers, we have just seen that we have to find this perpendicular distance PM, and PM is given by the formula a dot n minus d and divided by here we have divided by the magnitude of vector n. So this is the vector formula for finding out the perpendicular distance of a point P from this plane. So here if we see that the point P has the position vector a, and vector a is given by 2i cap minus j cap minus 4k cap, right? And the vector n is given as from this vector, that is 3i cap minus 4j cap plus 12k cap, and the value of d is 9, right? Okay, now here we have compared the equation of plane as r dot vector n is equal to d. Okay, so what is vector a dot vector n? So here we have 2 3s are 6, 2 times 3, then we have minus 1 times minus 4, and then we have minus 4 times 12, right? So this is 6 plus 4 minus 48, so this is minus 38, right? So the magnitude of vector n is square root of 3 square plus minus 4 square plus 12 square, right? So this is 9 plus 16 plus 144, and this is 169, and this is equal to 13. So therefore if we substitute all these values here, we get PM is equal to the value of vector a dot vector n is minus 38, and the value of d is 9, and here we have 13, right? So we can write it as minus 47 and divided by 13, that is 47 divided by 13. Now viewers, let us take this problem. Find the distance of a point 2, 5, minus 3. So this point is 2, 5, minus 3, and the equation of the plane is given by this vector equation. Now if we convert this vector equation to Cartesian form, we should write here for vector r, we write xi cap plus yj cap plus zk cap and dot 6i cap minus 3j cap plus 2k cap is equal to 4. Now if we take the dot product of these two vectors, we get 6x, the xx components, then yy components, we multiply y times minus 3, then z times 2, that is 2z, that is equal to 4. So this is the Cartesian equation of the given plane, right? Now this equation is now of the form ax plus by plus cz plus t equal to 0, and we are given the point 2 comma 5 comma minus 3 as x1 comma y1 comma z1, right? Now we know that the formula for this perpendicular distance PM is given by we have ax1 plus by1 plus cz1 plus d is and divided by we have square root of a square plus b square plus c square, right? Now if we substitute here the values, what is ax1? So we have 6x1 minus 3y1 plus 2z1 minus 4 divided by square root of 6 square plus minus 3 square plus 2 square, right? Now this can be solved as, here we have x1 is 2, so we have 6 2s are 12, then y1 is 5, so 5 3s are 15, and then we have z1 is minus 3, that is minus 6 and minus 4, right? Here we have minus 4, and divided by a square root of, here we have 36, then we have 9, and then we have 4, and it is 49, right? So if we solve it, we have 12 minus 15 is minus 3, minus 6 minus 9 minus 13, right? Minus 13 divided by it is minus 13 divided by square root of 49, that is equal to 7, right? And now this can be written as 13 by 7. So the distance of this point from this plane is 13 divided by 7. Now viewers, let us take this problem. Find the distance of the point from the plane. Here we have the plane 2x minus 3y plus 6z minus 2 equal to 0, right? And here we have the point P, say minus 6 comma 0 comma 0, and we have to find this perpendicular distance PM, and we know that this distance PM is given by ax1 plus by1 plus cz1 plus t, and divided by a square root of a square plus b square plus c square. So this is the formula for finding out the perpendicular distance from this point P to this point M. Now here we have this is x1, y1 and z1, and this equation of plane is your ax plus by plus cz plus t is equal to 0, right? So here we have 2x1 minus 3y1 plus 6z1 minus 2, and divided by square root of 2 square plus minus 3 square plus 6 square, right? And now if we substitute these values here, we get for x1 we write minus 6, so here we have minus 12, y1 and z1 are 0, so we have 0 0, and then we have minus 2, and this is root 49, right? Okay, now if we simplify, we have here minus 14 divided by 7, and this is minus 2, and we have 2, right? So the distance PM, that is the distance of this plane from this point, is 2 units, right? 2 units.